Okay, so today we are going to go over lesson 3. This is what I was absent for today because I was not feeling well. The video is going to be in, I think, 15-minute increments, and then I will embed them in Canvas, and this will count as lecture. So if after listening to this you are confused about something, please come and see me so that we can go over it. And before we move on to lesson 4, which we'll do hopefully Wednesday when I'm feeling better. So your checklist of things here is really to start getting us into thinking about doing math in chemistry, because we'll be doing quite a lot of math. And so exact numbers, uncertainty, sig figs, scientific notation, order of operations, these might be not new to you, but review. Rules, we'll talk about the rules for doing math with significant figures, and then also accuracy and precision and how they're different. So I am going to go over this question because it's an important lab skill. So if we have a graduated cylinder and it has, let's say, I'm going to draw it first. And say that it has 0.1 increments. So 0.2, 0.3, 0.4, 0.5, and so on and so forth. And let's say that we want to determine the amount of water that is in the graduated cylinder when it is about this full. Okay. Now, it's asking to which decimal place you should estimate. So if I zoom in, I can very clearly see that the water level is somewhere between 0.3 and 0.4 milliliters. But where it is in that range is the part where we have to estimate, okay? And so for me, I'm going to say, based on the meniscus, that this is probably 0.31 milliliters. Now somebody else might look at that and say, oh, I think it's 0.32 milliliters. And that's why estimating this second decimal place introduces uncertainty into our measurements. Okay, and that's where significant figures are basically, it's where they come from, is because we have this degree of uncertainty. So how can an exact number be easily identified? These are counting numbers. So if I can count them, then it's an exact number. So 12 eggs in a dozen, or 12 bagels in a dozen, in one dozen. That's an exact number. It's exactly 12 eggs, not roughly 12 eggs. Money is an exact number. You have an exact amount of money. There's no real question because it can be counted. And conversions, are they considered to be exact numbers? Yes, which means we're going to get to treat them differently when it comes to sig fig rules. Okay, so exact numbers and conversions are exempt from sig fig rules. Okay, so you guys probably haven't you haven't had lab yet. You may have had lab prior to this class, but two things that uncertainty might depend on in the lab is you, the user, either your knowledge of what you're doing or the limitation in your ability to do it right. And then there's also going to be called instrumental or tool limitation. So maybe you don't have a graduated cylinder that has decimal places, to the 0.1. Maybe it only reads every 5 milliliters. Well, your ability to know the exact volume when you only have 5 mil increments is less than if you had finer, more accurate 0.1 increments on a cylinder. Alright, so summarizing the rules. I'm going to summarize the rules very briefly because these are so important that y'all know them for the rest of this lecture and this class. So the first is that all non-zeros are significant. Okay, there are significant figures. Sometimes you're going to see sig figs, sometimes you're going to see significant digits. Sometimes when I grade your papers, I'm going to write SF, and that stands for sig figs, and I'm usually telling you to look out for them, okay, because you may have missed them. Then we're going to address the zeros. So leading zeros are not significant, okay? And leading zeros are things like, okay, these are leading zeros, and they are not significant. The next type of zero is trailing zeros, and they are only significant when they are left or right of a decimal point. Okay, so for example, this is 500, and it only has one non-zero, but these two zeros do not fall to the left or to the right of a decimal point, therefore they are not significant. So this would only have one sig fig. To show you what it means to be to the left and the right, if I write 500 with a decimal place, now these zeros are to the left of a decimal place and they are significant, which means this has 3 sig figs, whereas this one only had 1 sig fig. Okay, and then if I continue on with my example, the 2 zeros to the left, the 1 zero to the right gives this 4 sig figs. Okay, the rules with the zeros are probably the most confusing. Now, zeros that are between two non-zero numbers are significant, and we call them captured. So, for example, 505, this zero is between two fives, makes it a significant number, and therefore this has 3 sig figs. And this one up here only had 1 sig fig. So this addresses the 3 types of zeros. This also addresses the placement of the decimal point, how it's important. And I want y'all to think about the difference between precision and accuracy to answer this question. And if you're not sure, ask Dr. Smith on Wednesday, when hopefully she's back. Alright, so today you did your quiz. Bo is going to go work on grading the quizzes, and then I will work on the course participation points when I get back. Hopefully tomorrow. I'll be back. Okay, so one of the things we're going to do is we're going to spend about 2 lessons on essential math skills, because they are very important in chemistry and in lab. So we are going to go through using and converting to and from scientific notation. So when it's written like here, 1 and 2, this is called standard notation. Okay, and 3 and 4 is scientific. So it's pretty easy. You're moving the decimal to the left and the right, and you're going to move the decimal place to the left or the right until it falls between the first 2 non-zero numbers reading left to right. So in this case, it's going to fall between 5 and 6, because 5 and 6 are the first 2 non-zero numbers. And then we're going to rewrite all of the numbers as they were, with the decimal place in its new spot, and since we moved it 1, 2 to the left, it's times 10 to the second, and the positive number indicates that we moved it to the left. Now, to do this one, we're just going to go 1, 2, 3, 4, 5, 6, 7. Okay, so the 7 and the 7 are the first 2 non-zero numbers when you read from left to right. And because we moved the decimal place 7 places to the right, it's going to have a negative exponent. Okay, so make sure practice these if you are not familiar or it's been a while. Alright, so now we're going to go back from scientific to standard. So same way, we're going to go 1, 2, and we're going to rewrite this number. Remember, Dr. Smith's pet peeve is the 0 in front of the decimal place. Okay, so make sure that you, oops, I keep writing the same number, that you write this 0. It's not significant as far as counting digits, but it's significant to Dr. Smith. Alright, so I'm going to write this one out. 1, 2, 3, 4, 5. 1, 2, 3, 4. It's very easy to make a mistake on these because we get sloppy and fast and we think it's easy. So I recommend, I still write it out like this just so I don't make a mistake. Because once we start doing math, if you make a times 10 to the something mistake in just the conversion, then you're going to have a problem with your final answer. Now here, the reason why I want you to practice these in your calculator is because there's a couple of different ways to do it. Some calculators have the function that you can enter it like this. You enter 1.81, there's a times, there's a 10, and then it has this little boxy thing, and then you can enter in -2, right? Other ones, it's like 1.8. Mine has an EE, and when I hit the EE function, I just type in -2 behind it, and it will do this, okay? So I need you to practice this, okay? And if it doesn't work, come see me ASAP or Lexi and ACE, okay? And the reason why is because once we start doing math, I don't want you to make a mistake based on this exponent not getting entered correctly. You always have the option to unpack the number and put it in standard notation, but it does take time, so you just have to decide how you want to spend your time on questions like homework and stuff. Okay, order of operations. The rules of algebra are set up so that we have an order of operations. Most people say knows, please excuse my dear Aunt Sally, right? So it'd be parentheses, exponents, multiplication, division, addition, subtraction. And it's the order in which you carry out a multi-step process. Now in classes like quantitative analysis, you take care of the uncertainty at each individual step. But in Gen Chem, we are going to round at the end. Okay? So, for example, I'm going to take this problem step by step, and I'm going to add and subtract the things on top. So I get 118, -44, and then because on the bottom it's already just by itself, I'm going to solve that one. And now I'm going to solve the top by multiplying the denominators, rewriting the numerator, and at the end, I'm going to get this answer. Okay? So this isn't including doing sig figs with it yet, just making sure we remember order of operations. Now, on this one, I would encourage you to, if you're going to multiply, make sure that you're protecting the top, because sometimes what will happen is I just multiply all the way across on the top and I rewrite it just so I don't make any mistakes, and then that way if I get to the end and I'm like, there's not an option for this question, I can go back at each step and see, well, maybe I multiplied or rewrote this wrong or something. But calculators have a tendency to do this really weird thing where you do 2 times this, and then it divides the whole thing by 298, and then it does times 0.987 or something really strange like that, because it's trying to figure out the order of operations. So this is a good time to see, are you entering in things correctly on your calculator, because if you don't get this answer, then your calculator did a different order of operations and you wanted it to. Alright, we are going to practice marking the significant figures in these following measurements. We know they're measurements because they have units. Okay, so I'm going to try to mark them with a highlighter. So in this case, 4, 3, 3, they're all significant because they're all non-zero numbers. Looking at number 2, I know the 1 and the 5 are, and I know the 3 is. So if I think about what the 0 is, it is a captured 0. It also is to the right of a decimal place, which means they're all significant. Okay, so 3, 4. So the next one, we have 2 zeros in front and then 3, 5, 6. So we know that these are significant because they're non-zero. However, but these zeros in the front, these are leading zeros. They're leading up to the 3, 5, 6. So there's only 3 significant digits. These are not significant zeros. I could also put it into scientific notation and double check that, because when I'm in scientific notation, only significant numbers show up. And so because those zeros go away, in scientific notation it tells me that there was only 3 to begin with. Alright, in the next one, these 3 zeros fall after a decimal place to the right, and they are significant. So there is 4 significant figures. So let's go ahead and take this and put it into scientific, or into standard notation, so we can see what should happen to those 3 zeros at the end. So 1, 2, 3, 4, 5, 6, 7. So when I take something like this and move it into standard notation, those 3 zeros at the end must be included because they were significant over here on the left, and now they're still significant over here. Alright, next one is 50. So 5 significant, the 0, there's no decimal place to be found, it's not captured, so there is only 1 significant figure, and that's the 5. Now this one has 2 different types of zeros. There is a leading 0, which is not significant, and then there is the 0 that falls after the decimal place, which is significant, and then the 9 and the 5 and the 5. So there are 4. Now on this one, the last one, it says 5 pennies. So technically this is a counting number. So sometimes you're going to see it's one significant figure, and then other times, because it's a counting number, it's considered to be kind of infinite. Okay, so 5. Alright, the last little bit is addition or subtraction rules for sig figs and the multiplication and division. So you need to know these and make sure that you review them and don't mix them up with each other. So in addition and subtraction, answers cannot have more digits to the right of the decimal point than either of the original numbers. Okay, so that sounds tricky, but all you need to do is write it out. So in this case, sorry, I had to get a drink of water. In this case, what I want you to do is I want you to line up the decimal places just like you do or did when you first learned how to do math. Okay? Addition. And you're going to add everything up, and we're going to hope that Dr. Smith doesn't make a mistake. Alright, and then what you're going to do is you're going to find the number that has the fewest decimal places, and you're just going to draw a line right after it. So you see the 0 was the fewest, so I drew a line after it. And then I'm going to use the line to decide, do I need to round up or round down the number? Okay? And in this case, 5 and up, round up. 4 and down, round down. So in this case, my actual answer is 102.73. Okay, there's no units given to us, so that's the final answer. Same thing would be for subtraction, just subtract and not add. Now multiplication and division is going to mean that answers cannot have more significant figures than the original number with the fewest sig figs. So this is based on decimal places, this is based on sig figs. So in this case, this has 2 sig figs, this has 4 sig figs. So when I multiply them together, I'm going to get 11.2154. But because I'm limited to 2 sig figs, I can only have the first 2, which means the third number I have to figure out, does it round up or does it round down? And hopefully you all realize that it rounds down, and so my final answer is 11. Okay, now mixed calculations. In Gen Chem, when we have mixed calculations, you are going to round at each step. Okay, so if you had to do like solve for this first and then solve for this, and then you had to do something together, you would apply the sig figs at each step. Now, when you get to, if you get to a class like Quant, if you're a Chem minor or a Chem major, I think he teaches you differently, so just be aware that it only pertains for this class right now. So all you have is to work on the homework for just this one section. It's only one section of the book. Read the next section and fill in lesson 4. And then also bring your book and calculator to class. So book and calculator, okay? And then that's it. There's no additional reminders. Hopefully I'll be back tomorrow for lab, and then definitely by Wednesday. Please email me if you have any questions. Watch this as many times as you need to get the information. And then if you are still unsure, ask.